Let's take a look at the second question of the race number 0 of the Secureum Bootcamp. So here it says, the given contract snippet has an unprotected call to self-destruct, allowing anyone to destroy this contract. So do we have a call to self-destruct? Yes, we do. We have a self-destruct call here. Is it unprotected? Well, it is within the function kill, and this function kill is public. So anyone could call this function kill, and there's also no modifiers and no other checks preventing us from calling this. So it is indeed callable by anyone. To destroy this contract, that is what self-destruct does. It does destroy the contract. But one important little fact to know about self-destruct is that it doesn't destruct the contract immediately. It actually just marks the contract as to be destructed in the future. So basically when another contract is calling this function kill, the self-destruct call here will make this function return, so it goes back to the caller. But after that, this caller could call back into other functions of the test contract. It could still communicate with the test contract, it could still change the test contract state and everything like that, because all of the state of this test contract and the code of the test contract only gets deleted after the transaction is finished. And another thing to know about self-destruct is that it is actually being deprecated. You will notice if you use the most current version of Solidity and you try to use self-destruct in the code, it will actually give you a deprecation warning. And the reason why it's being deprecated is because in the future Ethereum wants to go from Merkle trees to Verkle trees. And this new form of tree for managing the state within Ethereum no longer allows for deleting all of the state of a single account, basically. So self-destruct will no longer be easily feasible, efficiently feasible, basically, and because of this they just want to get rid of it completely. There are different proposals on how to do it exactly and when to do it and so on. Everything takes time. This is decentralized. There is no CEO here who can just dictate us when to do it, how to do it. So everything takes a little longer. One of the proposals suggests that it should become a send all function, which just remains basically self-destruct does two things. It self-destructs the contract that is calling this, and it also transfers the funds of the contract to a specified address. In this case, to this address. And they basically just want to get rid of the deletion part and just leave the sending funds part inside. And this basically allows them to rename self-destruct to send all instead. So that's about self-destruct. So A is correct because it allows an unprotected call to self-destruct, allowing anyone to destroy this contract. Then B says that this contract snippet has dangerous use of zero address, leading to burning of contract balance. Yes, we have a use of a zero address here. Arguably it's dangerous. If we assume that we don't want to burn the funds, then it is dangerous, I guess. And burning and zero address is basically equivalent because there is no known private key for the zero address. So sending it to the zero address where nobody has access to is equivalent to burning the funds. So B is also correct. One important thing here again to know though is that this only sends ether funds. This is only the ether value that this test contract is currently holding. This does not do any transfers of ERC20 tokens or NFTs or anything. Anything else this contract is holding would still be stuck on this address. And the reason for that is that the balance where these ERC20 balances are stored isn't in a test contract, right? If you have a USDC balance, the balance of this test contract would be stored in the USDC contract. So even if this contract is self-destructed and all of its state is gone, the balance of this contract would still be in the state of the USDC contract. So be careful with that. And next we have C, a compiler error because of the use of the reserved keyword kill. And there are indeed reserved keywords in Solidity. A lot of them come from things like JavaScript and Python and so on, but there's actually no reserved keyword for kill. So we can use kill without any issue. And there is no compiler error. If we just paste it into Remix, we can see when we compile it, it only again gives us the SPDX license identifier. And if you compile it with a very new version of the Solidity compilers instead, we will also get the self-destruct deprecation warning, but we only get this if we use a very recent Solidity compiler version. If we use the version that was used in the snippet 8.4, then we actually don't get this deprecation warning yet. So C is not correct, and none of the above cannot be true, and that's that.